So dear children, we are in logic gates in the chapter Semiconductors from Riju and PSK classes. അതിങ്ങനെ ഇടയ്ക്കിടയ്ക്ക് പറയണമെന്നൊന്നുമില്ല, നിങ്ങൾക്ക് അറിയാമല്ലോ അല്ലേ, പക്ഷേ എന്നാലും അത് രസമാണ് ആ പേര് പറയാൻ. കാരണം ഈ വർഷത്തെ റിസൾട്ട് കണ്ടിട്ട് ആ പേര് പറയുമ്പോൾ നമുക്ക് ഭയങ്കര സന്തോഷമാണ്. നമുക്കും കുട്ടികൾക്കും പഠിച്ചവർക്കും നമ്മുടെ അലൂമിനിക്കും ഒക്കെ ഭയങ്കര സന്തോഷമാണ് റിജു ആൻഡ് PSK എന്ന് പറയുമ്പോൾ. ബിക്കോസ് ഇന്ന് നെക്സ്റ്റ് ഇയർ നമ്മൾ ഈ വർഷത്തേക്കാൾ നല്ല റിസൾട്ട് ഉണ്ടാക്കുന്നു 100% ഉറപ്പാണ്. അതിനാണ് നിങ്ങൾ ഞങ്ങളുടെ മുമ്പിലിരിക്കുന്നത്. നിങ്ങളിൽ തന്നെ വളരെ കുറച്ച് പേര് ഇപ്പം 1-to-1 ഇൻറ്ററാക്ഷനൊക്കെ നടത്തി കഴിഞ്ഞപ്പം നമുക്ക് മനസ്സിലാവുന്നത് കുറേ പേര് ഈ വർഷത്തെ റിസൾട്ടിനേക്കാൾ നല്ല റിസൾട്ട് ഉണ്ടാക്കാൻ റെഡിയായിട്ട് അവിടെ ഇരിക്കുന്നു എന്നാണ്. സോ ഇഫ് യു ആർ അമംഗ് വൺ ഓഫ് ദം, റിജു ആൻഡ് PSK ഉറപ്പായിട്ടും ഒരു അഭിമാനം തന്നെയാണ്. റൈറ്റ്. നൗ ലോജിക് ഗേറ്റിൻ്റെ ഡെഫിനിഷൻ പറഞ്ഞു, ഇറ്റ്സ് എ ഡിജിറ്റൽ ഇലക്ട്രോണിക് സർക്യൂട്ട്. It's a digital electronic circuit where that follows a certain logical relationship between input and output voltage. So there is a electronic circuit, okay? It has got an input voltage and an output voltage, and there is a relation between input and output. What relation? A logical relation. What is logic? Logic means what? Logic means reasoning or reasoning, logic. So there is a reasonable relation between input and output. That is why it's called as a logic gate. It's an electronic circuit. Fine. And there are five different types of logic gates named NOT, AND, OR, NAND, NOR. Those who learned computer science, avarku idoru prashname aayikilla. You already know all these things. Okay. These logic gates can be constructed using semiconductor device. That's why we study that here in this chapter. Okay. And these are used everywhere, electronic watches, everywhere, in the board, in the camera, in your mobile phone, computer, everywhere this is used. Okay. Now, this is called an integrated circuit. It's called an IC. It's an IC chip, a very popular, world famous IC chip. Okay. It's called 555. Not the 555 cigarette, this is 555 IC, 555. This is used in many circuits as a timer circuit, so many devices, okay. And such a circuit is actually inside, you see lot of components, resistors, so many devices are there inside this single IC. Diodes will be there, transistors will be there, resistances will be there. So everything in a compact, very small package is what we call as an IC, okay. Your computer has got one big IC. The CPU, the central processing unit, has got a big IC, maybe more than one IC in your computer, laptop, mobile phone, everywhere. You heard about a Snapdragon, all those words, Intel inside. It all represents ICs, bigger than this. Inside those ICs, what we use in smartphones on all these devices, we have logic gates, electronic circuits. You know how many? In one CPU, there can be as many as 100 million logic gates. In a very small one, 100 million small circuits inside a chip. These logic gates controls everything. Whenever you store data, when you take a phone, when you talk, like you call, you text somebody, you send a smiley, there are millions of logic gates working. That they process the signal. Even right now when I speak to the camera captures me, captures my voice and processes, and for this millions and logic gates are working inside the camera. Amazing. On my board, even if I am not touching, millions of logic gates are working in various parts of this circuitry. Even in my flash drive which I am using here, there are many thousand logic gates working inside, not thousands, millions. Okay. That's why we study them. Now, truth table is something that we use. It's not a table, it's actually a tabular form. A table showing all the possible input logical level combinations with their respective output logical level is called a truth table. It's a table where we write the input levels as well as output level. We have already done one while we discussed that switch thing, 0, 1, 1, 0. That was a truth table. Now listen, look at this diagram. I have a battery, a resistor and a bulb. This is a bulb and there is a switch here. What will happen if the switch is off and what will happen if the switch is on? See, a switch is simply a conductor, okay. if the switch is closed, if the switch is open, definitely a current will flow through this wire, through the bulb, back to the cell, and there will be glow in the bulb. So, switch off, bulb glows. Switch off, bulb glows. What will happen if I close the switch? If I close the switch, this will be a short circuit. Okay, that means potential at this point and potential at this point will be equal. There will be no potential difference between A and B. No difference between A and B. So, no current will flow through the bulb. No current will flow through the bulb because bulb does not get any potential difference. So, I will write the second step here. Switch on, bulb does not glow. If you don't understand this, your current electricity is not strong enough, even for NEET examination. If you don't understand this right now, you have to study current electricity basic from 10th standard, not from 11th, 12th standard, from 10th standard. Okay, that's it. Now, switch off of this switch can be taken as 0, opposite case is 1, 0 and 1. Bulb glows can be taken as 1, bulb does not glow can be taken as 0. That's marked here. Switch A open, 0, switch A closed, 1. Lamp on, 1, lamp off, 0. Now, look at this table. This is a truth table. It shows you all the truth about this thing. Input A equal to 0. A0 means this is open. Bulb glows, 1. When this is shorted, bulb does not glow. Okay. Now listen. What is output Y? What is Y? Y is that what A is not. Y endanu? A endanu adalla mattedanu. A endanu adinte appurathathanu. Y is what A is not. Y is what A is not. That's why we write Y is not A. Y is not A. Y is A is 0. Y is not 0. If not 0 means 1. A is 1. So Y is not A, not 1, it's 0. This can be written in another method. We can write Y equal to A bar. A bar means A complement or A inverted. That means if A is 0, Y is 1. If A is 1, Y is 0. This is what we call as a logical NOT gate. This is called a logical NOT gate, but this is using a cell, bulb, switch, etc. But you can use a semiconductor device, semiconductor circuit, and then we call it a NOT gate. We don't show the interior complex things inside, we only show the representative symbol. This represents an electronic circuit which will do that operation of giving you an output which the input is not. NOT gate is a one input, one output gate. Gate means circuit. Output is an inverted version of the input. It is also known as inverter. This is the logic symbol and this is the truth table. It's a triangle with a small circle in the output. Input is A, output is Y. Y is related to A, that is the truth table. Y is A bar. Okay? That is the first gate, NOT gate. Second circuit you can see here. There are two switches, a bulb, a battery. Just write what will happen if the switches are open or closed. You can see that again from your basic knowledge of electricity, if one of the switches is on, that will allow current to flow. If both the switches are off, if both the switches are open, no current will flow through this thing. Okay. So, this is switch A, switch B, this is the bulb output. Bulb is not B, bulb is bulb. Okay. A open, B open, no glow. A open but B closed. What will happen? If you close B, current can flow through that one. So bulb will glow. Okay. On the other hand, if A is closed, B is open, still through A current flow, that will glow. If both are closed, what will happen? Closed. Both are closed. That means current will flow through this one as well as through this one, the bulb will glow. Now let us write them using the binary number. Open means let us put a 0. Open means 0. Bulb does not glow, 0. Open means 0. Closed means 1. This is 1. Closed is 1. Open is 0. 1. Both are closed. Output is 1. So this gives you the input output logical relationship. So this becomes a truth table. Okay, now after observing you can understand that you will get a high output if at least one of the input is high. Got the point? Output is 1 if at least one of the input is 1. Output is 1 if at least one of the input is 1. If both are 1, then again you get 1, but if the inputs are 0, both are 0, output is 0. This is called the logical OR gate. OR gate means output is either this or that. Okay. An OR gate has 2 or more input. It can have any number of input, but in our syllabus you take only 2 inputs. If any one of the input is high, output is high. The previous one was only a demo sample. The actual thing is like OR gate uses semiconductor devices. Okay, but the working will be just like the previous one. So this is a symbol and this is a truth table, and we write the equation as y equal to A or B. This is written as A or read as A or B. A plus B is read as A or B. This is OR gate. Okay. Now look at this one. Again there are 2 switches in series. Work out the previous case. I can directly go here. If both the switches are open, there will be no current. Bulb will not glow. Bulb will glow only when both the switches are closed, right? This should be closed, this should also be closed. Only then you will get an output. So you can see both are open, no current. One is open, again it cannot conduct. The other one is open, again it cannot conduct. It can conduct only when both are closed. Only then the path is complete. So you can say the output is 0 if at least one input is 0. Output is 0 if at least one input is 0. Output is 1 only when all the inputs are 1. Okay. This is called a logic AND gate. A and B. Both A and B must be high to get a high output. 2 or more inputs with one. If any of the input is low, output is low. We write it as A dot B. We read it as A and B. These are the 3 gates. Not, or, and. Now you can make more of them. It's called a NOR gate. What is a NOR gate? OR gate followed by a NOT gate. It's like this. This is your OR gate. You connect this to a NOT gate. This is a NOT gate. So whatever output you get here, get inverted. If you get 1 here, it will become 0. If you get 0 here, it will become 1. Okay. Now, instead of drawing them separately, what we do is that the second part of the NOT, this entire thing, will be used here just like a circle. So this is the OR gate and the circle represents the NOT gate. So OR followed by NOT gate is what we call as NOR, not gate. Not OR, that's the meaning. Output എന്ന് പറഞ്ഞത് ORന്റെ output അല്ല, not the output of OR. How do we get that one? What is the truth table of OR gate? We know ഈ ഇൻപുട്ട് കൊടുത്തു കഴിഞ്ഞാൽ ഔട്ട്പുട്ട് വാസ് ലൈക്ക് 0 1 1 1. This was the output of a OR gate. And the new output here is not this. 0 കിട്ടിയാൽ 1 ആവും, 1 0 0 ആയി മാറും. So this is how the output of the NOR gate looks like. Now you should see here one important point. What will happen if both the inputs are 0? Output is 1. When both the inputs are 1, output is 0. So does it tell you something? Both inputs are 0, output is 1. Both inputs are 1, output is 0. How to make both inputs 1 or both inputs 0 simultaneously? Very simple. Okay, very simple. Both the inputs are same thing. Now shorted. Instead of giving two separate inputs, you give it a single input by shorting. That means if A is given 0, both the inputs will be 0. Both the inputs will be 0. So 0 0 will give you 1, 1 1 will give you 0. This will become a NOT gate. You give 0 here, you get 1. You give 1 here, you get 0. It's nothing but a NOT gate. So you can make a NOT gate using NOR gate. Simply short the input terminal, then the NOR gate become a NOT gate. Not using NOR. This is the diagram, that's the truth table. Next one, how to make an OR using NOR? OR using NOR. Very simple. What is it? A NOR gate. പറഞ്ഞോട്ടെ ഇതിൻ്റെ ലോജിക്ക് പറയാം. This is a OR gate. Okay. Now this is a NOR gate. Okay. Now connect this to another NOT gate. What happens? This is OR. Then again this circle represents NOT. This also represents NOT. So you invert it twice. OR inverted, again inverted. So this will give you OR. But instead of using this thing, we will use a NOR gate by shorted input. And we know this is nothing but a NOT gate. So how many NOT gates are here? This circle represents one NOT gate. This represents one NOT gate. NOT and NOT will cancel. You will get OR gate. So how to make OR using NOR? This is the NOR gate, another OR. Both are NOR. So using two NOR gates, you can make an OR gate. Confusing? No, take some time. You'll understand it. Okay. So I told you, you can make a NOT gate using NOR gate, or you can make an OR gate using NOR gate. Can we make an AND gate using NOR gate? AND using NOR gate. It's possible. This is the connection. Okay. This is the connection. You have 1, 2, 3 NOR gates. Okay. Inputs are A, B. Let us analyze it. Let us analyze this. Let us say the output that is coming here, let me call it as Y1. This output, let me call it as Y2. And again, this is, is a NOR gate and a NOT gate. So I'll say the NOR gate gives you an output Y dash and the final output is Y after an inversion. Okay, let me draw the truth table. So many columns. Why, I'll tell you. This is the final output Y. This is the intermediate output Y dash. See, Y dash is inverted to get Y. Okay. Then you have this Y1. Then you have this Y2. Then you have your A and B. And A and B has got only 4 combinations. 1, 0, 0, which is binary 0. 0, 0, 0 is decimal 0. 0, 1, that is the decimal 1. Then 1, 0, decimal 2, 1, 1, decimal 3. So if I think about decimals here, this is 0, 1, 2 and 3. Keep that order in mind, it's easy to write. See, now what is Y1? What is this gate? It's a shorted input NOR gate. So this is nothing but a NOT gate. NOT means if you give 0, Y1 should be 1. If you give 0, Y1 should be 1. You give 1, you will get 0. You give 1 here, you get 0 here. What is the logic? Logic is that this is a NOT gate. So whatever A, its inverted thing will come here at Y1. What about Y2? Y2 you can say that this is a NOT gate. This is a NOT gate. So B and A B and Y2 are complement of each other. So what is B? 0. So this will become 1. What is this? 1 will become 0, 0, 1, 1, 0. Now this is a NOR gate. So this is an OR gate. It's an OR gate followed by a NOT gate. Okay. So what is the output Y dash? Output Y dash. You just combine them. Or 1 and 1 will give you 1, 1, 0 will give you 1, 0, 1 will give you 1, 0 will give you 1. Clear? Now, this is inverting. This small circle, you see, this small circle is inverting Y dash. So, it will give you 0, 0, 0 and 1. Now, you compare this thing and the last thing. And you will see that this is an AND gate. So, you can construct NOT, OR and using this super gate which is called NOR gate. So, NOR gate is called universal gate, because using NOR gate you can construct all other gates. If you have understood what is the meaning of a NOR gate and how it can be used in constructing NOT, OR and AND, now you can think about something similar to this. What is it? A NAND gate. NAND gate is AND followed by NOT gate. So AND gate with a circle, inverted form. So whatever be the output of AND gate, it should be complemented, inverted. So you will get a 0, 0. 0 and 0 in the AND gate will give you 0, but here it will give you 1. Similarly, you can see all the other inputs here. Fine. So this is called a NAND gate. And the equation is written, Y is, see, normally for AND gate we write like A dot B, but this one is inverted, so complement. This is actually A complement plus B complement. You can work out. It's called Boolean algebra. Okay, computer students might be knowing it. It's called Boolean algebra. Some basic equation. Y A dot B complement, A and B complement is equal to A complement or B complement. This is it. Okay, this is what we call as a NAND gate. Now using NAND gate, you can construct other gates. Shorted input, you will get a NOT gate. Just like the previous one, work out and see that 0, 0. You can see the previous this thing. See, if the inputs are 0, both are 0, then 1, both are 1, you get 0. That's why we provide that mechanically by shorting the input. So you can give only one input here, either 0 or 1. If you give 0 here, you get 1. If you give 1, you will get 0. This is a NOT using NAND gate. Next one, how to produce AND gate using NAND gate. You can use a NAND gate, then a shorted input NAND gate. So this will complement the output again. So there are two complements. AB is complemented here, again complemented. So you will get to the AND gate. Now the third one, how to produce OR gate using NAND gate. Just like the previous example of NOR gate, we can take various inputs and intermediate outputs like this. So call this as A and B. Order, hope you know this by now, 0, 0, 0, 1, 1, 0, 1, 1. Then you can write Y1 here, Y2 here, Y dash here, Y here. Which is Y1? Y1 is output available here, Y2 is output available here. Then I mark here in between, this is Y dash and this is complemented as Y. Now 0, 0, that's a NOT gate, right? A and Y1. I can write the Boolean expression. What is Y1 is nothing but A bar, Y2 is nothing but B bar, and Y is what? What is Y? Y is Y1 dot Y2 and operation, that is Y dash, and what is Y? Y is Y complement, which is Y1 complement or Y2 complement. This is actually OR operation. So you are basically getting OR operation. Okay, let's see this. Okay, and you can see Y1 is A bar, so Y1 bar is actually A. Y1 bar is A, and y2 bar is b. So you can prove that this is Boolean proof of proving that its output is a plus b. 0 and 0, y1 is the complement of a, so you'll get 1, 1, 0, 0. y2 is the complement of b, so you'll get 1, 0, 1, 0. y dash is the AND operation of this thing, 1, 0, 0, 0. And this is the complement of that one. And you can see that if you compare the input given and the final output, you can see that it's an OR gate. This is proof through truth table, and this is the Boolean proof. This is not there for your syllabus, don't worry about that one. Okay. Now, finally, logic gates. What is the logic of learning about logic gates? നമ്മൾ എന്തിനാണ് ലോജിക് ഗേറ്റ്സ് പഠിക്കുന്നത്? എന്തിനാണ് ലോജിക് ഗേറ്റ് പഠിക്കുന്നത്? ഇതൊന്നും ചോദിക്കുന്നില്ല, വേറൊരു ചോദ്യം ചോദിക്കട്ടെ. ഓക്കെ, ഇത് ഏതാ സബ്ജക്റ്റ്? ബയോളജി ആണോ ഫിസിക്സ് ആണോ? നിങ്ങൾ വിചാരിക്കണ്ടോ ഇത്രയും പഠിപ്പിച്ചിട്ടാണോ ഇയാൾ ചോദിക്കുന്നത്? ബയോളജി ആണോ ഫിസിക്സ് ആണോ? ഈസ് ദിസ് ബയോളജി ഓർ ഫിസിക്സ്? ലോജിക് ഗേറ്റ്സ്. I wish that ഉണ്ണിത്താൻ സാർ, സുമി മാമും പ്രശാന്ത് സാറും അനിൽ സാറും ഒക്കെ ഇത് കേൾക്കുന്നുണ്ടെന്ന് ഞാൻ വിചാരിക്കണം. കേൾക്കണമായിരുന്നു അവർ. ഇത് ബയോളജി ആണോ അതോ ഫിസിക്സ് ആണോ? ലോജിക് ഗേറ്റ്സ് അത് ബയോളജി ആണോ ഫിസിക്സ് ആണോ? ഇത് ഞാൻ നേരത്തെ ചോദിക്കണമായിരുന്നു നിങ്ങളോട് ക്ലാസ് തുടങ്ങുന്നതിന് മുമ്പേ. അപ്പോൾ ഇത് പഠിക്കുന്നതിൻ്റെ ലോജിക്ക് മനസ്സിലായാൽ. ലോജിക് ഗേറ്റ്സ് എന്ന് പറയുന്ന കോൺസെപ്റ്റ് ഫിസിക്സ് അല്ല, അത് ബയോളജിയാണ്. It's there with you, it's there with me. Living things-il think ചെയ്യാൻ പറ്റുന്ന എന്തിനും they have this logic operation. Maybe not the electronic circuits ഉണ്ടാവില്ല, പക്ഷേ ഈ logic operations ഉണ്ടാവും. That's why we study about them. എന്തിനാണ് പഠിക്കണമെന്ന് വെച്ചാൽ it's there in nature. ക്രിയേഷനിലുള്ളതാണ്. ഒരു കാര്യം പറഞ്ഞോട്ടെ, ലൈക്ക് ഇപ്പോൾ നമ്മുടെ ജീവിതത്തിൽ ഐ എം ആസ്കിങ് ലൈക്ക് യുവർ പാരൻറ്റ് ഈസ് ആസ്കിങ് യു ലൈക്ക് ടുമോറോ മോർണിംഗ് വാട്ട് യു വാണ്ട് ഫോർ ബ്രേക്ക്ഫാസ്റ്റ്, നാളെ ബ്രേക്ക്ഫാസ്റ്റിന് എന്ത് വേണമെന്ന് ചോദിച്ചാൽ യു സ്റ്റാർട്ട് തിങ്കിങ്. അസ്യൂം ദാറ്റ് ദേ സജസ്റ്റ് ഓക്കെ രാവിലെ മോർണിംഗിൽ കഞ്ഞി മതിയോ എന്ന് ചോദിച്ചാൽ എന്തായിരിക്കും നിങ്ങളുടെ ആൻസർ? കഞ്ഞി മതിയോ രാവിലെ ബ്രേക്ക്ഫാസ്റ്റിന്? കഞ്ഞി മതിയോ? ഐ നോ വാസ്റ്റ് മെജോറിറ്റി ഔട്ട് ദെയർ വിൽ സേ നോ. ദാറ്റ്സ് ദ ഫസ്റ്റ് തിങ് ദാറ്റ് കംസ്, നോ. അപ്പോൾ മദർ പറയാണ് ഓ ശരി ഓക്കെ കഞ്ഞി അല്ലെങ്കിൽ ഓർ റോട്ടി ചപ്പാത്തി ആയാലോ? സി മേ ബി യു ലൈക്ക് ചപ്പാത്തി ബട്ട് ഓൺലി വിത്ത് സർട്ടൻ ഡിഷസ്, സൈഡ് ഡിഷസ്. അപ്പം നിങ്ങളുടെ അടുത്ത പോയിന്റ് എന്താണെന്ന് അറിയുമോ? നിങ്ങൾ ചോദിക്കും റോട്ടി ആൻഡ് ചപ്പാത്തി അമ്മയുടെ പൊട്ടറ്റോ കറി ആണെങ്കിൽ നോ. ചപ്പാത്തി ആൻഡ് ചിക്കൻ യെസ്. സോ every time you make a decision, every time you think, every time you talk, you always have these logic operations of a not, and, or. It's happening here in your brain. Everything. Right now, when you listen to me, when you think about those things, examples and all, millions of these operations are going on in your brain. Anything. Let me stop my class. Suddenly you are happy. Stop my class. And that's the first thing. Sir, class stop ചെയ്തിട്ട് എന്താ ഇനി പറയാൻ പോകുന്നത്? ആൻഡ് വാട്ട്? ഇനി ഇത് ഇവിടെ ഇരിക്കണോ ഓർ ഞാൻ പോകണമോ? അതോ സാറിനോട് നോ എന്ന് പറയണോ? എവറി ടൈം എനിത്തിങ് ഹാപ്പൻസ് ടു യുവർ മൈൻഡ്, ദിസ് ഈസ് ഹാപ്പനിങ് ദെയർ. ലോട്ട് ഓഫ് നോട്ട്, ഓർ, ആൻഡ് ഓപ്പറേഷൻസ്. ഇനി കുറച്ച് നേരം ആലോചിച്ച് നോക്കൂ. തിങ്ക് അബൌട്ട് ദിസ്. ശരിയാണോ എന്ന് ആലോചിച്ച് നോക്കൂ. ഇത് തന്നെയാണ്. ഇപ്പം എൻ്റെ മുമ്പിലുള്ള ക്യാമറാമാൻ പോലും ഇപ്പോൾ ആലോചിക്കുന്നത് അതാണല്ലോ, നോട്ട് ആൻഡ് ഓർ എന്ന് പറഞ്ഞാൽ അതാണല്ലോ എന്നാണ് ആലോചിച്ചുകൊണ്ടിരിക്കുന്നത്. ശരിയാണ് ഈ പറയുന്നത്. ഞാൻ ക്ലാസ് നിർത്തട്ടെ എന്ന് പറഞ്ഞാൽ ഉടനെ നമ്മൾ അടുത്ത ഓപ്ഷൻ ഓർ എന്താ ചെയ്യേണ്ടതെന്ന് ആലോചിക്കും. ആൻഡ് അതിൻ്റെ കൂടെ എന്ത് വേണം? ഇനിയിപ്പോൾ ലൈക്ക് +2 റിസൾട്ട് വന്നാൽ ദിസ് ക്വസ്റ്റ്യൻ വിൽ ബിക്കം വെരി സീരിയസ് ഫോർ യുവർ ലൈഫ്. ബിക്കോസ് നിങ്ങളുടെ റാങ്ക് സ്കോർ ലൈക്ക് സപ്പോസ് ബോത്ത് യു ആർ റൈറ്റിംഗ് ബോത്ത് JEE ആൻഡ് നീറ്റ്, യു ഗെറ്റിംഗ് വെരി ഗുഡ് സ്കോർ ഇൻ ബോത്ത്. വാട്ട് ടു ഡു നോ? എന്ത് ചെയ്യും? You have to say no to one of that and choose one the other, or choose both. No, അത് പറ്റില്ല. Alright, so you decided to go for MBBS. Okay, So when you decide to go for MBBS, then again questions comes. And decided MBBS and which college? AIMS or Chennai or Trichur? See, overcoming. You decided, okay, I am going to Trichur Medical College. Trichur Medical College. Then only MBBS and something else. And after that, this is coming. Every time, whatever you do or not to do, these things will come. That's why I say this is there here. Your brain is doing this. This amazing work is done by your brain. That's why I say it's biology. And in physics, in electronics, in engineering, we are simply adopting this. Or maybe not even adopting, we are mimicking it. Mimicking the mighty operation of brain. Why? Because we want machines to think. That's it. We want machines to think. And machines started thinking already. It happens every time you operate a computer or a mobile phone. Can't play this video. Many times you have seen this. Cannot play this video. Android. It is thinking. It is telling you. It's not possible. PowerPoint. Do you want to save the changes you made to semiconductor TC1418? This is my document. I just press that into button, close button. So suddenly the computer is asking me, Areva, you decided to close the document, it's okay. But do you want to save this? Do you want to save this? Yes or no, or cancel. What is it? You have taken a very dumb decision of closing the document, and do you want to cancel that decision? It's asking me. When I decided to delete my recycle bin, suddenly computer is asking me, are you sure that there are 18 items in my in here? Do you want to delete all of them? And sometimes very serious. Your PC ran into a problem and it needs a restart. Who is doing all these things? It's done by the brain in your machine. Be it a smartwatch, be mobile phone, computer, laptop, anything digital things. And that thinking is through logic gates, through the semiconductor devices, through the semiconductor circuits called logic gates. We want these machines to think like us, or maybe think better than us. So it's biology transferred into engineering. More details in the next class. Bye.